So let's start with the simple introductions. My name is Vyacheslav, or Slav for short, and I work as EMEA's team manager at Elecard, which means that I cover the sales and the client representation in the Middle East, Europe, and Africa, which is very nice. I have background in management and business, and I also come from the IT stuff, kind of for business. So I'm not afraid to get my hands dirty on bigger projects that involve IT and IPTV and OTT, so practically the whole hour market that as we know it. But unfortunately, as we all know, you can never know anything in full. So today I'm joined by my colleague, Dmitry, who is the head of support and integration department, which effectively means that he is a very smart guy who knows the technical side of the questions and products that we will be covering today. I'm very happy that you found time today to join me for this quick session. And again, I will try and do my best to make it as light and as entertaining as I can, because some of the questions and the examples we'll be covering are quite difficult to cover at a glance level because they demand a more technical explanation and insight. But we are all smart people, and I'm pretty sure that you'll understand what I'm talking about. So again, a quick session schedule. We will be talking about our company, Elecard. We will be covering our product, which is Elecard Boro, and we will be covering 4 major examples of issues and stream errors that I personally have experienced with clients in the past, let's say 5 years in this business. Those are very interesting questions for the transport and perception layer. I'm pretty sure that if you work in digital media delivery systems, you will be familiar with the issues that I'm going to be cover. I will also cover a OTT specific error that also exists and I have had the pleasure of working with, and SCTE35 insertion problem, which is a more niche topic, but it's still very interesting to know because it is one of the things that can be considered and done with our product and solution. Again, at the end of the session, we will have a quick Q&A session. Then you can ask a question as we go along during the session, as it is. You can ask questions in chat, and we also have a Q&A tab. You should write your questions there. We will cover all of them at the end. And we also are going to have a quick poll. And at the end of the poll, you can answer some questions, and you will have a chance to receive a 30-day trial of our product, which is usually 7 days, but you can get it for 30, so you can test it for a longer period. Okay, so as we move along, again, do not forget to write your questions. It's very important. Now, as you know, we are working in OTT and IPTV with CDNs, ISPs, and telcos business, which means that we all kind of in the same boat, effectively. We do our best to stay on top of our video quality and stability game in order to provide the best content and the best quality of video content to our clients and do it as much and as fast and as cheap as we practically can. But there is a problem. The markets we're working in are not limitless. So effectively, you only have that many clients that you can cater to. And unfortunately, or fortunately, depending on how you look at it, the clients are having more and more chances to ditch your system and switch to someone else faster. Effectively, if you have a client that is using your service and taking your content as your provider, and if they don't like it, they can switch to something else like Netflix or your competitor. I'm sorry, but practically within minutes. And that is the root cause of the topic that we'll be discussing today, because minor problems that are not addressed are essentially the case and the reason that will drive your client base away from your company. What I mean is, if you have a big problem, if your stream goes down, if everything goes black, and you're not delivering content to your clients, it's noticeable, effectively. You will know immediately because we all have systems in place that will notify us or even try to prevent and save your stream from such a collision. But if you have problems that are small, tiny issues, tiny errors that are harder to detect and even harder to fix, that's where the problem lies because your clients will notice it. If it's a small packet loss, if it's some tiny jitter in the video signal, they will notice it, they will react on it, they will post on social media and ditch your platform and go to your competitor, essentially. This is the root cause of the problems. Error in broadcasts have a direct impact on operators' revenue, essentially us. Small problems are going to eat away at your profits. We have to stay on top of our potential problems by using tools that help prevent and solve them quickly. Essentially, anything that you can use, you should use. And anything you cannot, well, that's a good choice for you. We have to take proactive measures to always stay on top of things. So, and this is exactly where Elecard comes in. Elecard as a company has been in the business for 35 plus years, and we had a number of clients, both small and big, that have come to us for our products and solutions, and we have helped them improve or even create their own systems to monitor and deliver the content from point A to point B, which is essentially the source, to the client's playout device. We have multiple offices, effectively two, HQ in US and another office in Vietnam, and we're opening two more in Saudi Arabia and Europe soon. It's still pending. Elecard has three major development branches, which is the video quality monitoring systems, live quality analysis for videos, and video encoding. I will take a quick minute to explain them all. So quality monitoring is exactly what we're taking a look at today. It is Elecard Boro. It is a solution that is used to monitor your live streams. For video quality analysis, this is products that can take a video file, a recording of a stream, and analyze it on a deeper level. So you can check the GOP, frames, quantization, packets, PIDs, headers, that kind of technical stuff. For the live encoding, we have our own platform that actually takes any input you can throw at it, and it remultiplexes, restreams, encodes, decodes, practically takes anything, it does anything with your stream to make it compatible with the device that you wish to have. Plus, we've been in business for 35 years. We have our own SDKs, we have our own video components, and we do custom development for projects of bigger scale, effectively. So back to the topic. Today, we will be discussing a quick outreach, so we have a hassle-free environment for our video content delivery. Effectively, what we need to confirm is that the source of our video, which can be anything from a camera to a VOD system, is delivered through the pipeline to the playout device without any issues or problems. And that is why Elecard Boro is one of the best solutions on the market to help you and catch any small issues and errors that you can have. We'll see it later on. So, what is Boro? Effectively, if you go to our website, elecard.com, you will see a description for it, which states Boro is IPTV monitoring software solution for UDP, RTP, HTTP, HLS-SRT, and RTMP stream quality control and measurements of QoS and QoE parameters in all segments of distributed networks. That is a mouthful. Effectively, what it means is that Elecard Boro is a system to monitor live streams. Let's imagine a little example. Consider this. Your video stream pipeline is a road. You have the source and you have the destination, the playout device and the VOD system. Little packets of video stream are traveling down that road. They go from the source to the playout. On that road, many things can happen. Effectively, your packets can get lost, your packets can get collided, replaced, arrive at the wrong time, at the wrong place, get stuck in the cloud. There is a lot of things that can happen with packets, especially with the CDN systems nowadays. Now, here comes the Elecard Boro. Elecard Boro consists of two parts. Part one is the Elecard Boro server. Usually, this part is hosted in the cloud, but other deployment solutions are available. And the second part is Elecard probes. Elecard probes are little software snippets. It's actually software codes and executables that can be installed in your video stream pipeline. For example, you can install them at the video encoder, after the video encoder, packetizer, before the CDN entry, after the CDN, and even emulate a playout device and even work it that way. Essentially, returning to our example of a road, our little probes are tiny gateways for our little packets to pass through. Why this is important to understand? Elecard Boro is a scalable system. Effectively, if you have one server, you can have as many probes as you need or want. Essentially, this means that you can have one probe at one location that will monitor all of your streams, which is doable and totally fine. We have solutions like that. We also have systems where there are tens, if not hundreds, of probes deployed for hundreds of probes and streams, which is also doable, and we have clients like that too. Now, as for the cloud server. Now, as I mentioned before, Boro by default is a software as a service solution, which means that usually when you register your trial account, which you can go and check on our website, elecard.com/live-tv-Boro, you will be able to use our cloud server to monitor your streams. You do not have to worry about any hassle with the AVS deployment or local installation or any configuration for that matter. If you register a trial account, you will receive pre-configured probes. So you don't have to mess with the installation or configs for them too, which is very nice. So effectively, you can go from registering a trial account to using our solution in full within 15 minutes. But I have to stress it enough for the European systems and European clients, essentially. In some cases, and it is totally viable solution, Boro server can be deployed on location. So on premise, you can have a physical Boro server. It can be deployed as a software. It can be deployed as a pre-configured package solution. You can also host Boro server on your own cloud, which is totally fine. Essentially, this is done to prevent any regulation problems, especially in Europe. Now, let's take a quick look at Boro itself. So when you register a trial account and you use Boro, this is the first screen you're going to see. This is called Live View. Essentially, you can see that from the left to right, the probes and signals are showing the information that they receive. Of course, this is just a snapshot, but in reality, if you go to our website, which is in the chat description, you can take a look at the live demo and see the same information. So Live View shows all the streams that you have, and it scrolls from right to left. If it's green, everything is okay. If it's yellow, there are some small problems, usually a blip of a one packet delivery problem or some small issues with the playlist loading. If it's orange, and you can see little orange blips on this graph, it's a bigger problem. Now, orange, you should take a look at, but it's not catastrophic at this point. It usually is something to do with packets delivery or something like a momentary loss of signal, for example. Now you can see there's also red. Red is bad. Red essentially shows bigger problems that are close to catastrophic. Essentially, in this example, red is loss of source. If there is no source, there is nothing to show. So that's very bad. There is also two other options to be shown for each stream. This is black and blue. Black is practically very, very bad. It's a catastrophic failure, and there is nothing in terms of compression going on. And the blue is a video freeze, which is also very important to understand because some systems use video freezes for maintenance and work time, and it can be pre-configured to ignore it. So that's a very nice feature to have. Now, as we move along, let's return back to our example. As I said, Boro consists of two parts, the Boro server and little probes. Now, our probes will never, ever in any way affect your stream. This is not their intended purpose. Probes are only for monitoring. They do not alter, they do not change anything in the streams. It is not a solution to fix a problem. Boro is a system to monitor. So your stream will never be delayed, no matter how many probes you install, and your system will never get bogged down, nothing like that. Boro probes are used only for monitoring. And again, the main idea is if you deploy multiple probes at multiple stages within your environment, again, at the encoder, packetizer, CDN entry, and the playout device, as a brief example, Boro the little packets as they travel from the source to the playout device will pass through those probes, and those probes will check information that the packets contain. So this is the source, destination, content, delivery queue, what's the location, and how fast are you going effectively. But when the information mismatches between the probes, that's when they will detect it and they will signal the server. They will not change, they will not stop the packets or do anything to it. They will just say, hello, server, this packet has just passed through this specific point and it provided the wrong information from the previous point. So something happened between these 2 points. This is the whole idea of the system. It is effectively how it works. Now, as we move along, and again, this is very hard to understand for some people, the Boro is a system to monitor and notify. And notification is one of the biggest things that you should configure when you're using the system. Boro has an extensive system configuration for notification. For example, if you have a system that you know works perfectly, you can configure it to create only logs, effectively just gather the information and send it by email every once in a while. So maybe in a couple of weeks or once a month for you with your engineers to parse and review. You can also configure Boro to notify you by email, webhook, which is practically API at this point, Telegram, and even configure it to have a sound alarm blare at maximum volume if something goes wrong. This is very important if you have a system that is unstable or unpredictable effectively, and you need to be notified immediately if something breaks. If it's a small issue, a packet loss, or some tiny delay delivery of the packet, it's okay. You can notify it by email, you can log it, it's fine. If it's a bigger issue, like content delivery or complete loss of the signal, you need to be notified immediately. So, because this is an emergency. Also, because we're talking about a system that works 24/7, 30 days a month, and 12 months a year, effectively all the time, ideally, the data collected is become big data, essentially what is known as. So if you have a lot of data, the system can take it and analyze it not on a weekly basis, but at a longer periods. For example, this is the KPI view. KPI view is very important if you have a system that works perfectly, but you consider or have hindrance or some hints that it might start to deteriorate. This is very important to understand because looping back to my initial point, small problems in your stream will chip in and practically eat out your client base. So small problems like, let's say a packet loss once in a week. If you lose one packet in a week in a stream, it's not a problem, effectively. It's just some small glitch or some delivery issue. If you lose 10 per day, again, it's not catastrophic, just 10 packets and the backup system can just probably cover it. There will be no significant impact on the video stream itself. But if you have a 10 packets lost per week, next week it's 10, next week it's 12. That's a problem. There is an issue for that. It's either a hardware deterioration or there is a problem with software. Maybe it's buffer overflow on one of the packetizers, one of the switches in an environment. You do not know. If you detect it at the playout device, you know that there is a problem. You don't know where. If you have Elecard Boro deployed as a system with probes at multiple locations, you will be able to pinpoint the location of the actual problem before it even starts to happen more and more and actually affect your video stream. The KPI is effectively what it is. It is a report that is generated over time. The KPI is all the availability that you have for your stream in the long run, and it shows you if your stream is available 100% or if it starts to drop to 99.9, 99.8, then you have to start to actually consider things to be changed. Okay, quickly covering some other stuff. Elecard Boro, of course, is designed for big and small systems. It is very scalable. So if you have only a handful of streams, it's fine. It's not a problem at all. If you have 200 streams, that's a lot. So you'll probably need a lot of information to cover. So this is block view. Block view is a compressed view of all the streams that you have. So if you don't need to see all the small problems, small issues happening at different points, this is a nice way to look at them. This is a drill down. This is effectively, you can drill deeper into one of the streams and see all the internal parts of it. You can see the TR101 to 90 notification settings and presets. You can see all the technical information, and you can even see the bandwidth and composition of your stream. This is very important to have if you're tweaking the configuration for your encoder, because any changes in the encoder, you will see on this graph live view. And of course, because Boro is a massive system and can be deployed at multiple locations with different hardware, again, you can also get notifications about the actual hardware for the probes. Hardware for the probes is a very interesting topic too, because Boro probes are very hardware light. They don't have to be installed on separate servers or anything like that. We have clients that have deployed Boro probes on Raspberry Pi devices. little tiny dongles with practically no hardware at all. So this is very important to know and monitor too. Okay, at this point, we have covered all the major things about Boro that you should know before we dive deeper into the questions about the errors in the streams and the problems that I have encountered I would like to share with you. So if we have any Q&A questions, do not forget to write them. It's always good to check. Okay, so let's now dive deeper into the actual examples that I have for you today. There are going to be 4. It's going to be transport level problem, it's going to be perception level problem, it's going to be a specific OTT oddity that you might find interesting, and it's going to be an ad insertion issue. So let's start with my favorite, transport layer problem. This is live information taken from one of our clients that has generally agreed to share this information for me to use in this presentation, so I can show it as an example. Do you see the problem here? Of course you can. There is a problem. There is a gap in the information being received. So this client has a little TV system that gets information from a source, and he has multiple probes installed within the system. This is a probe at the encoder, packetizer, and CDN entry. And within the environment of the client, everything is perfect and everything is fine. They get good source and they send out a good signal and everything is nice and tight and the video is crisp and great. But over time, they start to get some replies and feedback from the customers that say that the video is bad, that there is some drops and problems with it, and they get cancels. So cancels is the biggest problem, essentially. So if your system is perfect, but your clients are canceling, there is a problem. So what we did, that client came to us and say, we have the system, we monitor it, and everything is fine, but we have this issue. So what we did, we deployed another probe as a playout device. So now the client covers the whole pipeline from the source to the destination. This is the source, and within the client's pipeline, this is encoder, packetizer, CDN entry, and playout device now, 4 probes in total. What we gathered is, and of course I need to highlight the issue because it happens on the screen, there is a problem with packet delivery after the CDN. So if it happens after the CDN, it is an issue with hardware or software, essentially, of the telco or the ISP, so essentially the last mile provider. We see that there was a hardware issue that caused the timestamp discontinuity, which caused the stream to collapse. There was no signal for a tiny period of time, essentially just a few seconds, but still. No signal means that there is an issue, and the clients notice it, and they're not happy. Essentially, in this example, what we did, we collected the logs. Well, we helped the client to collect the logs, the specific information, how to analyze and parse it, to confirm that the issue happened not within their environment, but after. So that was the issue with the ISP, telco, or the last mile provider. When we help the client to collect this information and push it down the line to confirm with the actual last mile provider, they were able to confirm, yes, that there was an issue with the hardware that they had after the pipeline. Essentially, in this scenario, Boro helped to detect an issue that was outside of their scope. They can monitor and know what happens within their system, but not after it. But with Boro, they can, because they can emulate the playout device and put a probe there. Second example, perception level error. This is a more interesting one. Again, this is a real example from a real company that shared the information with us. Different part of the world, different scale. This is a small TV studio that is running their system, and they get a couple of inputs from different cameras. They convert it, compress it, and send it to a social network. Pretty simple example. We have clients like that too. So the client uses the system, and everything, again, looks to be pretty fine within their environment. But as soon as it goes out to the social system, they start to have issues on that front. So they use probe. They install Elecard Boro, they run the probes for a couple of months, and they see this happen. Again, it's pretty simple to spot the problem here. Essentially, it is a bump in the encoding of the stream. What this means is, again, the client asks us to help to parse and analyze the information that they got from the Boro probes. And what it means is, this is a problem with encoders. Essentially, this is a bad source. By default, the client had it configured for the stream to be received at 24 FPS. But sometimes, for some technical problem or reason of the delivery, we do not know yet, the client was receiving 20 FPS. So if you have the encoder configured to receive that specific type of FPS and it receives less, it has simply no information to get in and compress and send it down the line. From the visual standpoint of view, it works. There will be no problem with the visual part of the stream. It will be a video file that's going to be played and converted, and the users will see it. Maybe some tiny glitch with the visual part, but not perceptible by an eye. The problem arises when this stream is re-encoded later at the social network entry. The social network takes the stream, re-encodes it again, and because of the mismatch in the FPS, it creates an issue. And that issue is harder for the stream to work with. So essentially, in this example, we had the client that had bad input. Again, they can monitor what happens within their environment, but what happens before it, it's harder to contain. Okay, the next one is a very interesting one, I find. It was sent from our clients, which is a good companion of mine. It is an OTT oddity. I'm pretty sure you might find it interesting. Can you spot the problem on the graph? I'm pretty sure you can. So if you can see, there are packets being delivered at the interval hops on the graph, and then there are none. And then there are again. So quick explanation of this one. This is a client that is running a CDN. Within the CDN, they have deployed multiple probes at multiple hops. So essentially just, again, multiple parts of this stream and pipeline. What they have discovered is that the system works fine, flawlessly. Content is delivered, no hiccups, no problems. Hardware is working 100% perfectly. No issues in that regard. But since they're running Elecard Boro inside of it, it collects data, and again, running over time for extended periods of time, it collects big data. Boro has started to show this specific error. The error is that one of the packets has 0 bytes inside of it. How can it be? It happens for some reason, and that's actually a very interesting part, because we do not know why. This is still an ongoing investigation, but I just wanted to share this information with you. So the packet that is arriving contains no data in it. You might say, okay, fine, it happens because there is backup data in the previous packet and the next one, and the overlay at the encoder and packetizer can parse the information of that video stream, and it's going to be fine. But again, looping back to my source and the main reason of this discussion, if you have tiny, small problems that happen over time, again and again and again, they will grow one day into a big problem. And you do not want that. So if it's just one packet loss per day, you might think it's just a hiccup, some tiny problem, maybe just a short overflow. If one day it happens to go into a full, complete collapse of your stream or network, it's a very, very bad thing. So to summarize, Elecard Boro within this CDN network detected an issue where the network itself thought there is none. You can see how this can be helpful, especially if you're running a bigger network with multiple hardware encoders, decoders, and packetizers along the way. Boro takes a deeper look on a different level. You have confirmation systems, you have automatic analyzers, you have systems that are built into your hardware that check the packets, that check the stream, that says everything is A-OK. But a problem like this can still get through that system, pass under it, get unnoticed, and cause big issues later on. Okay, moving on to my last interesting example of work how Boro can be used is the ad insertion issue. This is the STTE35 insertion and stream validation system. Some of us know, especially if you're in the market and you work with advertisers, you will know what it means. But you have essentially multiple markers within your stream that say, hello, we're going to insert an ad here. We're going to insert little ad segments here, 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 here. We're done, continue with the stream, which is fine. But sometimes issues might arise. Essentially, this can be led by a iframe or a bad insertion protocol. It happens. It happens, essentially, I have to admit, with a lot of clients, and they are not very happy about it. But the thing is, Boro detects ad insertion. Boro detects all of the STT35 markers, but in this specific example, we're only looking at the ad block beginning, the actual ad insertion, ad end, and block end. When Boro detects that there is an advertisement block incoming, it will switch to a turbo mode. What is a turbo mode? By design and by default, which can be configured in the settings, Boro takes little snapshots of your stream, essentially screenshots, every single second. This can be done to ease the load on the actual hardware used for the probes and ease the load on the actual net side of your system. But Boro takes screenshots every few seconds, which is fine. But if you're trying to find an issue or to detect an issue, or you need to see a specific point where an ad is inserted, a frame every second is not going to work because it cannot predict when it's going to be inserted into the system itself. So when Boro detects a beginning of a net segment, it switches into a turbo mode and starts to take snapshots every single frame. With every single frame, we can confirm that there is the ad insertion, that it was done properly, there is no issues, there is no problems, and the ad is played as it should, as you can see below here. Again, this is done by detecting the SCT35 markers. This is very important to understand because some companies are working with advertisers, and advertisers can be very, very stingy if they pay to show their very expensive ad that they have recorded to be shown at the very specific time of the day, only to find out later on that the ad turned into this. This is a good example of bad ad insertion. This is a collision of iframes and packet delivery. This is what Boro is trying to look for. And if it can find it, you can have a pinpoint the location and time when and where it happened, and you will be able to analyze and later find out why. Again, Boro is not a fix. Boro is not a solution. Boro is a system to monitor and notify you as soon as it happens. And as soon as it happens, you have the information, the logs, the actual screen recordings, because Boro can record the actual stream itself upon a trigger, like SCT35 insertion mark, and you will be able later to analyze that specific recording to see why. You can take a look, for example, in StreamEye Studio, which is another product that we have, and you can see the composition, frames, their interdependency. You can see the quantization. If there was a problem with the encoder, you will be able to find if it was that. If it was a problem with the actual packetizer and delivery network, the system level error, you'll be able to use Stream Analyzer and see if it was a problem with the PIDs or headers or any of that. Cool. So again, to help prevent and have a little bit of information for the advertisers to show later, we have created a turbo mode in Boro that will make a little recording of an ad insertion that you will be able later to show with your advertiser to confirm that the ad was played at a specific time on a specific channel and it was played okay. Now, again, I would like to remind you that we've been in business for 30 plus years. We have products for monitoring of the video streams. We have products for deep video analysis that can show you the actual packets and frames. And we have solutions for live stream encoding. Okay, at this point, this covers the main questions that I have for the session. And we can take a look at the Q&A. Okay, so I go to the Q&A tab and I see a question that was asked. One of the questions that was asked is, can you make a screen recording? Yes, as I just covered at the best SCT35 example, Elecard Boro can be used to be configured to make screen recordings as little TS dump shorts. This can be configured to be triggered upon any specific trigger that you can configure in Boro. It doesn't have to be SCT35. No. Understand this. This is a monitoring system. So if you suspect that you have a problem with the TR101-290, if you suspect that you might have a problem with buffer overflow or underflow for that reason, you can configure Boro to trigger a screen recording, well, essentially stream recording, on that specific trigger and record a chunk of the stream to be saved for later analysis. Okay, I see another question. Do you have integration with data miner? And that is a more technical question that I will pass an answer for that to my colleague, Dmitry, who is in the chat with us now. Dmitry, hello.
Hello, Vic. Thank you. Thank you for this in-depth explanation, this webinar. So yeah, I was typing the answer for this question. Yes, we do have the integration with data miner. We just finished our integration process, and now we are ready to provide to the customers who are in need, the integration adapters to integrate their DMA systems with our Elecard Boro. So yeah, this is fully supported.
Sounds good. Sounds good. That's a good answer. Okay. I would just like to remind you at all, again, that this session will be available as a replay and hosted online. You will have a link in the email as a follow-up. And you can email us all your questions. If you don't have any questions right now, or you don't want to type in a Q&A, or you're saving your very good question for later on, you can send us an email at sales, and we will be able to take a look at it, analyze it, send to the correct department, say, is it a dev problem? Is it a technical problem? And we will reply to you with the most information that we can provide.
Slav, I think we have some questions in chat that might be not visible to all of the attendees. So maybe we need to like pronounce them and to make sure that this information will be available for everybody.
Okay, if you can you take one question?
Yeah, sure.
Thank you.
Yeah, the first question was regarding the. So let me just read it. I think that Boro can monitor streams in IP networks, unicast and multicast. Yeah, that is correct. But do you have a solution that can monitor streams in DVB-T, DVB-C, and DVB-S networks? Maybe a separate box that has a Boro and a tuner. So the reply is yes, indeed. So this is the good question. We are now working actively on DVB probe at the moment. So actually the probe and the tuner, and we expect to get a better version for this probe in the following month or two. So if you have some upcoming projects, or you have some current needs in that, so we will be glad to receive your requirements, your needs, and we will be glad to work together to satisfy your needs. So yeah, I see the latest question. Is it possible? Yeah, is it possible to group different streams in one monitoring group so we can segment the stream, for example, of one server? Yes, we do have this option as well. Actually, we call it consolidation, and this feature actually was designed to combine multiple streams in one, let's say, group, or we call it service. This way, you will be able to group any amount of streams under one service name, and this will allow you to get the information about the group of the streams in more, like, let's say, efficient way.
Yes, I would like to just point out again a very simple fact that Boro is scalable. Again, this can be used by clients as small as little startups with a single camera, single PC encoder that sends the signal to a social media site. Boro can be used. Single probe on the PC that is used, and it's totally fine. Boro can also scale as big as an IPTV network. And this is a very poignant question, because you can imagine if you have an IP network, an IPTV, or an OTT one, you can have as many as hundreds, if not thousands, of streams. If you imagine, and if you recall, with the live view with all the green lines, that would effectively means thousands of green lines to scroll through and look at every single one of them. That would be tedious, yes. So we have a separate view for that. It's called either a block view or consolidation view that compresses that information into a smaller color-coded chunks. Again, if there's going to be an issue, you will be notified, you will see the red chunk on top of everything, and you will know that there is a specific problem with that specific group on that specific probe. So in terms of notification, yes. In terms of grouping, yes, it can be done. So it's not a problem. Thank you guys for participating in this session with me. I hope it was very insightful for you to learn something new about our product and what kind of problems it can help solve you, and what type of issues I think are the most prominent in the environment. Again, remember, if a big error happens, you know about it and you can fix it fast. If something small happens, it starts to gnaw at your client base and they start to run away to your competitors, because the market is not limitless, and the clients have a lot of options to switch to other service providers, content providers, anyone. It is a big thing. This is the business and the actual kind of a premise that we live right now and work with. So we need to stay on top of our game to be the most dependable, essentially, against our competitors. And our system is designed to help you do exactly that. Okay, if there are no more questions, the Q&A is clear, the web chat is clear. I think we can be done for today, and that should be good. So again, thank you very much for participating in this session. And I hope you'll join me for the next one that we'll have, hope pretty soon. So see you there.